Welcome again, and this is the first step of week 1 in the Beginner's Guide to Environmental Science. And in this step, we're going to talk about what is environmental science. And environmental science is actually a wide swath of things. But before we even begin to delve into environmental science, let's first talk explicitly about what the environment is. The environment is actually a couple of different things. First, it's all the living things that we would associate with the environment. It's the trees, the grass, the plants, the birds. You can hear people in the cars behind me because I'm filming in a park. It's all the living and non-living things in the world around us. And those non-living things include the atmosphere, the rocks, the ocean, the ice sheets, all of those things that we wouldn't consider living. Now, the other part, it's not just the living things or the non-living things, it's also how those things are arranged around and within each other. So it's the geography of those components. It's the mountains and the forests on the sides of the mountains. It's the oceans and the ocean currents and the fish and the algae and the diatoms in the oceans. It's how they're arranged, the geography. And that brings us to the last part of what the environment is. And this is the really interesting part, and this is where I get goosebumps on my skin and I love talking about it. It's the interactions between all those living and non-living things and those patterns that you see in the environment. And it's these interactions and interconnectedness that are at the crux of environmental science. Because what it means is that anything we do has an impact on the environment. And anything that happens in the environment might have an impact on us. When we're looking at these interactions and interconnectedness, we often talk about relationships. We sometimes, if we're looking at statistics, we'll talk about correlation or significant relationships. And this is a way of quantifying some of these interactions and interconnectedness. And it's really important in environmental science when we start talking about the environment and the impacts, that we have this idea in our head that we can actually not only look about the relationships, the qualitative relationships of our environment, who acts on what, but we can look at the quantitative relationships in those environments as well. How much does that animal act on that plant, or how much impact does that plant have on the CO2 levels of the atmosphere? Finally, I just want to take a moment to remind ourselves that humanity is part of the environment. And it's those interactions and relationships that mean humans can have an impact on the environment, but likewise, the environment can have an impact on us. And I think we know this. You read the news every day, you see storms, droughts, they have an impact on human society. And likewise, humans, whether it's fossil fuel use, groundwater, aquifer use, lots of different ways, our waste generation and landfill use, we have an impact on that environment. And it's always a dynamic system where our impacts can be reflected back on us, and the changes in the environment reflect on us, and we can reflect those back into the environment as well. It's always a two-way street. Humans are an integral part of nature, and we will always be so. And I think it's really important to not remove ourselves from the conversation, but to put ourselves into it. And when we look at what environmental science is, and remind ourselves that we're not just an observer when we're doing environmental science, but we're a participant as well. So what is environmental science? Environmental science is an interdisciplinary academic field that seeks to describe and quantify those interactions and relationships between the living and non-living things in the geography of our environment. And I think it's really cool because it covers a whole broad range of topics, from kind of the easy ones to think about, right? Biology, ecology, chemistry, to ones that you might not think are related to environmental science, but are still sciencey fields: mathematics, information science, chemistry, physics, right? Those are still an integral part of environmental science. And it goes even further: law, social sciences, history, archaeology, anthropology. All of those are a part of environmental science as well, because all of those describe interactions and relationships of living and non-living things in the world around us. A great example of the interdisciplinary nature of environmental science is to look at annual CO2 emissions. The figures I'm showing you here are the CO2 emissions per capita per year of Qatar, Mali, United States, Canada, Australia, China, and India. And notice here that Qatar has a huge circle with respect to its CO2 emissions per capita. Remember, this is the nation's total CO2 footprint divided by the number of people who live in that nation. So it's essentially how much CO2 every person in that country emits every year. That's what this graphic shows. And it's interesting because Qatar, the people of Qatar, on average, use a lot of CO2 or emit a lot of CO2. And that's through activities like driving, air conditioning, power generation, lots of different activities. Same thing in the United States, Canada, and Australia. We have relatively large CO2 per capita footprints. China has a medium-sized one, India has a relatively smaller one, and Mali is a small dot off on the left side of Africa. Now, that's because Mali, people in Mali on average don't consume a whole lot. They don't have a lot of vehicles, they don't use a lot of electricity, and that's an issue around history, geography, economics, sociology. Again, those are things we don't often associate with environmental science, but because their interactions and relationships are crucial to our knowledge. If we look at the next picture here, you can now see that Qatar has shrunk. Why did Qatar shrink? Well, because even though each person in Qatar has a large CO2 footprint, there's just not a whole lot of people in Qatar compared to China or India. Now also notice that India doesn't have a huge circle, but it's much larger because over 1 billion people live in India. Same thing with China. Even though China had a relatively small footprint in the first figure, it's now got a huge footprint because it's got over 1 billion people who are using energy, they're driving cars, they're doing things. Look, here's where it gets interesting. One of the reasons Qatar has such a high CO2 emissions per capita is because Qatar has easy access to fossil fuels, which is not just a matter of history and geography, it's a matter of geology, chemistry, and physics. Also, think about the oceans. And as the atmosphere warms from all of these CO2 emissions, there are going to be countries, especially low-lying islands in the Pacific and Indian Ocean regions, which will be impacted more than inland China or inland Mali or inland United States or inland Australia. So all of these things, chemistry, physics, geology, history, socioeconomics, all come together to make environmental science, because these are all aspects that environmental science encompasses. So what good is environmental science? Look, environmental science is really important because it helps us to put figures and information into the hands of policymakers, and it helps us make better decisions. And that's really important if we're going to develop sustainable solutions for the future. So environmental science addresses all sorts of issues. Environmental science provides actionable information for just some of the wicked problems in the world today. Maybe degradation of the natural environment from pollution, the increasing consumption and demand for natural resources, the decreasing availability of finite resources, the increase in extinctions and the decrease in biodiversity, and the fact that no more land is being made, except the demand for that land is increasing, from agriculture to urbanization to the need to preserve our wild spaces. Don't despair. There's hope. And one of the things and the example that gives me the most hope is that in the 1980s, environmental scientists began to realize that something was going on over Antarctica, and that the ozone, which is so important in shielding the Earth from ultraviolet radiation, was decreasing, and they called it the ozone hole. When scientists realized that the ozone was decreasing over Antarctica, which would lead to increasing skin cancer rates, especially in Australia and New Zealand, which are close to Antarctica, they realized something needed to be done. But first they had to find what was the cause of this effect. When they realized the cause was chlorinated fluorocarbons, or CFCs, that are used in refrigerants, they gave that information to policymakers, and policymakers got together and said, hey, you know what? We can do something about this legally and through law. And they created a law called the Montreal Protocol, which then acted to reduce the amount of CFCs that were used as refrigerants around the world. This reduction in the use of CFCs has led to a regeneration and an increase in the amount of ozone in Antarctica and has begun to close the ozone hole. So humans realized that they were having an effect. They sought out the cause. Once they realized what the cause was and what the effect was, they came up with a solution and they implemented it. And really, that's the heart of environmental science.